So class, good day to everyone. So this is to officially start our lecture using our video lecture medium moving forward for the rest of the semester. So as you have all known, our semester will be done purely online. So all the lectures that I'm going to be sharing with you will be based on this video lectures or PowerPoint presentations that I'm going to be sharing with everyone through emails or messengers. I hope this methodology will be efficient for everyone or can be of any help in trying to understand what lectures are we trying to cover for until the end of the semester. So if you have any questions, just send me a message into our messenger, group chat in the messenger, and I'll try to answer it as much as I can. And if not, and I'll be trying to reach out to you via email or via another video conference call. Okay, so our topic for today will be focused on what we call Z transform. So Z transform. Z transform is the methodology of simplifying a signal coming from a time domain, simplifying a discrete time signal coming from a time domain and converting it to a frequency domain. So analysis of system and its signals or its discrete time signals would be simple and easy to analyze. So that's where this is really helpful, especially when you're analyzing complex signal. You wanted to make it more simple or make it the analysis of this signal would be simplified for its use. So how does the Z transform comes into play, or how do you do a Z transform of a signal in a time domain converting it to a frequency domain? So take note of the basic formula for what we call Z transform. So Z transform is represented by this formula. X of Z, which is your Z transform of your signal, is equal to summation of X of N, which is your original signal, Z negative N, wherein your N is equal to negative infinity to positive infinity. So this is your basic formula for Z transform. So take note that there are two types of Z transform. So the first type is what we call the unidirectional transform. Unidirectional transform is when your signal is only on the positive N. So this is what we call so-called right side transform, which is your N is equal to 0 until N is equal to positive infinity. Another type of transform or classifications of transform is what we call the bidirectional transform, which is the opposite of unidirectional, which is you're dealing with two locations or two sides, which is N is equal to negative infinity to N is equal to positive infinity. But for the first part of our Z transform, we're going to make it simple, and we're just going to be dealing with what we call unidirectional transform, or one-side transform, or right-side transform. But before we begin, I want you to remember or recall your summation of infinite geometric series. If you remember your infinite geometric series, This is what we do when, let's say you have a specific variable. Let's say your variable is a, and you keep on multiplying it by a constant term or a common term. Let's say a common term r. So when you get the summation of that, or a plus a r plus a r squared plus a r cubed plus a r fourth plus n dot 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 a raised to r raised to infinity. This is what we call infinite geometric series. Or if you simplify it in a common term, this is how we express your infinite geometric series. Summation of your first term, or your term, times r raised to n, wherein your n is equal to 0 to positive infinity. Right? So how would you, if you remember your statistics, so simplify this. This is just equal to 1, or a, or your first term. This is your first term, and this is your common term. Oops. Common term. And if you're gonna simplify it, common term, the simplified version of the infinite geometric series, or the mathematical equation for that, is what? 1. You already forgot? Okay, so a, this is your common term, over 1 minus your common term. This is, for your case, it's a over 1 minus r. So this is what I want you to remember in terms of dealing with Z transform. This is very important because all the formulas or all your Z transform will be, your objective is to make it on this format. Once your signal is on this format, you should be able to get your Z transform using that one. So let me make an example for everyone. Let's make another page. Okay, now let's say example number 1, which is your x of n is equal to, let's say a given is u of n. You know that u of n is already a right side signal, right? So any number or any value of x of n or u of n is equal to 1 as long as your n is greater than or 0 to positive infinity. So for your x of z, so using the same formula, summation of n is equal to 0, since this is a right side transform, u of n, z negative n. Right? So since this one, n is equal to 0 to positive infinity, so this one is equal to 1. So your x of z is equal to 1, summation of n is equal to 0 to positive infinity, 1 times z to the negative n. So does this form look familiar? So what is your a? A is equal to 1, r is equal to z. So the summation from n is equal to 0 to z to positive infinity, or summation of n is equal of z to the negative n when n is equal to 0 to positive infinity. So that's going to be x of z is equal to common term, first term, 1 over 1 minus, what's your common term? Z. Oh, something is missing. Z negative 1. Right? Okay, so if this is the case, this is your Z transform. But for this lecture, I want you to express it into a positive power or positive coefficient. So if that's the case, multiply the entire equation by Z over Z to make it positive. So this goes Z over Z minus 1. Okay, when you're dealing with Z transform, so this is your x of Z. So x of Z is equal to Z over Z plus 1. Oh, minus 1. When you're dealing with Z transform, it means that you're converging your signal into a single point of convergence, or tinatawag natin na region of convergence. Region of convergence. Dito, nagko-converge or nagjo-join. Convergence. Yung signal natin when we convert it into a frequency domain. So how do you get the region of convergence? Your region of convergence is kung saan yung denominator mo or yung signal mo hindi siya magiging infinite. Paano ba siya hindi magiging infinite? So for your case, ang palatandaan ko lang, kapag right side transform, para makuha mo yung Z, yung region of convergence mo, kunin mo yung nasa denominator. Yung nandito sa right side, yun yung Z, region of convergence mo. So your region of convergence is absolute value of Z greater than 1. Bakit? Kapag ang absolute value ng Z mo is greater than 1, you always make sure that what happens? Yung nandito sa ilalim, ano nangyayari? Paliit ng paliit yan. Tama ba? Kapag greater than 1 siya, ibig sabihin more than 1 yung denominator ko. Tama ba? Kapag more than 1 yung denominator ko, or laging positive yung denominator ko, ano nangyayari sa signal ko? Hindi siya lumalaki. Ang value ko ng signal ko ay laging nasa controlled environment lang, or lagi lang siya nasa positive, or hindi siya aabot ng infinity. And kapag dinonowin nyo siya, or meron siyang on a top view, meron kang tinatawag na unit circle, or ito yung coordinate system mo. Pero for this case, this is frequency. So this is 0, 0.0. Ang greater than 1 is ito yung 1. Z is equal to 1 and Z is equal to 1. So magdodrawing lang ako ng circle. Ang region of convergence ko na tinatawag is greater than, or greater than daw siya sa absolute value 1. So ano mangyayari? Nasaan yung greater than? If this is 1, this is less than, this is tinatawag na region of convergence. Itong portion na to. So that's what is Z transform. Okay. So that's the first example.